Alright, hopefully this is live. Let me know in chat if for whatever reason it is not or you're having any issues with the stream. But today's stream, or right now at least, is going to be kind of a relaxed, just going over diagnostic processes on M1 machines and writing wiki articles about so. So this is going to be a very informal stream. It is probably going to be fairly boring, so if you're not into that, feel free to skip this one, but I'm going to get started here and just go over this. So I'm going to be writing wiki article on this, and the first topic we're going to cover, and I don't like this, so I'm going to change. Nope, this is good. Alright, so the first thing that we're going to go over is 5 volts and 0.0 between 0.05 amps on the USB amp meter. So let's do this. Zero point 0 to 0.05. So 0.05 amps as from speed-c meter. And what I like to go over on these is I like to form on pretty much all of the articles I've written on here. So let's take a look at the A1932. I wrote this right here. Just briefly go over this, make sure this is up. Alright, so what I like to do is I like to list a differential diagnosis. So what a differential diagnosis is a list of problems that are possibly the issue. You go through and rule them out. So on particularly the A1932, we have all this listed of what this might be. PP bus G3 hot, shorted, device stuck in DFU mode, absent or shorted 3v3 G3H RTC, failed CD3217. Most of these can be very similar on the M1 machines, but that's how I like to go through each problem. Having a differential kind of helps you on, hard cases because it gives you a list of stuff to think about that you could then form a conclusion for and go through and rule stuff out. So that's what I did. I did all of this on this page, or at least most of it, as well as the power sequencing of where everything comes from. Alright, so we're going to do the same thing on the M1 machines. We're just going to start with no power. I may actually change the 0.5 to 0.2. I think that might give it a little bit better representation because some faults may fall out of that at times. So problem 2, we're going to write the same thing that we did on the A1932, which is the most common cause of 5 volts and 0.0 amps is going to be a short on PP bus AON. That's not going to change on the M1 machines. That's still the most common cause, and the ones that we've seen is 5 volts, 0.0, 0.01, 0.02. A little bit out of that is going to be PP bus G3 out missing, usually from a short to ground. So we're going to get that listed on this one as well. So let's just go ahead and pull up our page for the A1932 right here. And I am going to just copy what I can reuse here. And we can actually change this a little bit. We will have to change it a little bit, but I'm going to reuse some of this right here. So let's go down to where I have this. And my phone is ringing. I will be right back. And the person hung up after about 2 rings, and we stopped calling people back when they call us and hang up immediately if we don't answer right away. Some people have this unrealistic expectation that you have to answer the phone right after the first couple rings, and they hang up, and then we stopped calling them back because nearly every single time called them back, they're pissed off that we called them back. So I stopped calling people back. Normally calling people back that have hung up on the first ring or so, first couple rings, they just hang up on you or they complain about something, and it's just not worth calling them back. So if they don't stay on the phone between the time I get up out of my chair and walk to the phone, then you know what? I don't care. So this is weird here. What's wrong with this formatting? Yeah, I'm just going to redo this. Sometimes when you copy something from a wiki article, it just kind of gets screwed up. So bullet point here. Yeah, some people expect you to be superhuman, and I mean, like, and what the thing is it's not a rare thing. You know, you'd expect, okay, you have one person that got upset that you didn't answer the phone on the first one or two rings, but it's actually quite prevalent. Um, yes, 2016 to be stuck on 5 volts and 0.00 to 0.02 is a short. I'm not gonna put a short. I'm gonna put is PB bus underscore AON voltage low or missing. Common cause. I'm going to check. Always check that both USB-C ports are reading. Always check that are reading the same before. I'm not going to put before proceeding. Are reading the same. One port reading 5 volts and let's say 0. Which is 10 to 0.25 is more. Let's see. Well, all the other reads. Ism CD32 17 issue, then issue with PP bus AON, or what are they calling the rail that powers the CD3217 on these? Let's see, Galvani is here. The Korg, thank you for donating $2. The Korg M1 is superior to the Mac M1. I don't know what the Korg M1 is, so I'm gonna Google that here. And that is a synthesizer. They're two very different things. And I'm gonna put my board view here. Let's drag this over here. And we're going to figure out where on the 820-2016, where is it here? I know I've looked at this board view many times. We'll just open a new one. .2016 BVR file. And here we go. Alright, so here's our CD3217s. Let's see where these guys are being powered from. I'm going to guess I think they have a different name for these. I mean, I don't know everything off the top of my head, but let's figure this out. So we have our input, PPHV. That's our input from our AON line. I mean, from our USB-C charger. And then we have our output, which is PPV bus USB-C 1. It used to be called something other. And in this case, the way they're doing this is a little bit more complicated compared to the CD3217s. So generally, if any of these rails are missing either PP5VS2 or PP3V3S2, any of these, if they're missing, then that can cause issues. Let's just go over, just so we understand before we're writing, or before I understand before I'm writing, how these rails are generated. So we have PPV bus USB-C 1, and let's figure out where this comes from. So PPV bus USB-C 1, where is it? So we have 2, that's normal. That's each output. I want to figure out where this goes to. And what kind of trickery are they doing here? Here's the USB-C. It looks like this is the USB-C. Oh, no, it's not. Okay. That's interesting. Yeah, it is. Okay, I'm being dumb. Yeah, what I don't like is when they change net names. Okay, so this is our USB-C in voltage. This is going to be coming from a charger or USB-C, and this is either going to be 5 volts or 20 volts. It goes into the chip. Normally you have a MOSFET externally. The CD3217 does not have an external MOSFET. The MOSFET's actually in the chip. And then this is going to shoot out voltage to the rest of the system. So PPV bus USB-C. And then that's going to carry on over to our ISL. I know it's going to go over to our ISL, and it's called something else right here. So people in chat, looks like I just dropped the stream, so please let me know if it comes back. Are we back? Looks like we are. Okay. So our USB-C voltage is going to go over to our ISL 9240. I'm not going to go through every single thing about how this works here, but our USB-C voltage makes it over to here. This chip right here, U5200, produces PP bus G3 hot. It's a gate driver. It's going to drive a few MOSFETs here. Okay, these guys right here, and that's going to produce PP bus AON, which I'm guessing is going to supply PP5VS2. Now, I want to figure out where PP5VS2 comes from on this. So, where does PP5VS2 come from? Okay, so we see, I'm looking for coils, so, alright, that's keyboard backlight, I don't care. Alright, here we go, here's something that looks familiar, PP5VS2, so PP5VS2SW, so this is going to be our coil for switching, and looks like UC3000 is going to produce PP5VS2, and this is sourced from PPBus. Again, it has a funny name, and we could probably find a current sensing resistor if we look hard enough. And right here, there's a current sensing resistor, and you could see that this is powered from PPBus AON. So PPBus G3 hot remains the first rail that we need present in the system for anything else to work. So if PPBus is not present, then none of the USB-C controllers are going to work, and none of the rails that the USB-C controllers require are going to work. So you know this comes from U3000, UC300, so we know that. Now, let's go back to our schematic. So, back over here. Okay. So we know where that one comes from. Travis is here. Hi Travis, how's it going? What did I just do? There we go. Here, Travis will get a moderator. Okay, so we know where PP5VS2 comes from. Now, typically, typically these chips, the USB-C controllers, have many functions. They have a little CPU part of them. They do many things, and each of the parts of the chip are usually powered by an independent power rail. Before on, no, I don't think Thomas is talking about, I don't think Travis is talking about you, Thomas. So on older boards, we needed PP3v3 G3 hot or PP3v3 G3 hot RTC. And that was it. Now, on the CD3217s, they're a bit more complicated, and they need many rails. So we know PP5VS2 comes from UC300. Now let's go and see where PP3v3 S2 underscore UPC comes from. And this one's important because we can see on the chip it says VIN 3v3. Now, VIN 3v3, that's an input to the chip. That's probably important. So let's go ahead and look for the same thing, PP3v3 S2 underscore UPC, and let's find where this comes from. So PP3v3 underscore S2 underscore UPC. No, not that. UPC. Okay. And again, I'm looking for where this might come from. Okay, so we're looking, we see resistors, that's probably an input. Alright, these are an input to a chip, doesn't come from there. And I just lost it. I'm looking for inductors, and I'm looking for where a power rail is coming from. I'm looking for an inductor, and I look at and I see this over here, U8100. Let's see, where does this come from? Does this have an inductor? No, but this looks like a PMIC, and that could very well be an output from the PMIC. So there's a bunch of buck converters around here. I don't know if this is an output or if this is an input. It's hard to say right now. So we're just going to keep looking and see if we find anything else that may look like it's produced from. I'm looking for coils. I'm looking for current sensing resistors, or shunt resistors I should call them. And this one is this looks like an E-fuse actually. UF2300. What is this? Is this an E-fuse? No. And that's a VCC. So it doesn't come from there. Let's continue. Okay, what's this right here? That's not it. That's an LED for debug. Alright, so where was it here? 3v3. Okay, let's look on the schematic and see if we can't trace this back now. So this one's might be a little bit more complicated, and I'm not quite sure where this comes from. So U8100, here we go, VLDO7. Okay, so this is a LDO, a load dropout voltage from U8100, which is a proprietary PMIC. So that's where that comes from. That's a PMIC. Comes from our PMIC. Now let's figure out where our PMIC is being powered from. Now let's just kind of look. I'm looking for anything that says like VDD main or anything of the sort. And typically you'll find that on caps around there. And oh look, PP3V8 AON VDD main. So we've already kind of figured out our power sequence a little bit. We're figuring out what rail needs to come first. We don't have anything official from Apple. We're kind of reverse engineering this. So this PMIC is going to be powered by PP3V8 AON VDD main. Now let's try and figure out where this comes from. So PP3V8 underscore AON underscore VDD main. So AON stands for always on, so we could kind of assume that's going to be an always on rail. And you can see this powers a lot of stuff right here. So we have some capacitors here, we have a chip here. Alright, so I'm just looking at this chip, and I see PP3V8 AON underscore DRVH. That sounds like something that might be driving a MOSFET. I'm looking here. Alright, so I have two MOSFETs here. Oh, look at this, PP3V8 AON SW. SW typically means that it is a switch, and that means that we are driving a buck or boost converter, usually. Not always, well, I should say always, but in 99% of cases, it's going to be driving a MOSFET. And we have three phases here, similar to how we have CPU phases, and on this side we have PP3V8 AON phase 1 and PP3V8 VDD main. Alright, so that's where that comes from. Now let's figure out what is the source on these MOSFETs. So where is power being sourced from? Looking up, okay, PP bus AON, simple enough. PP bus AON. PP bus AON. So we need to have PP bus AON first, and that still stands with these. Any weird inputs in this chip? Where's this chip taking power from? Let's have a VIN here. Yep, PP bus AON right here. So PP bus remains that first rail that we need. And VIN is PP bus AON again. So that's our next clue. So our PMIC needs power. We figured that out. We just figured out our PMIC needs power. We figured out that, let's see. Alright, so we know where this comes from now. What about PP1V5, 1V25SO? How do you like this M1 so far? Any good to work on? So the 820 2020 and 820 2016 are very easy devices to work on. The newer M1 Pro and M1 Max look like kind of a nightmare, but so far success rate on M1 machines has been 100% in every single one we got in. That's a good thing. Alright, so PP1V25S2 is our next rail we need to trace down. PP1V25 underscore S2. Where do you come from? Where do you come from? Alright, I'm seeing, alright, this looks like that's nothing. And what's this? L. L stands for coil, and this looks like a coil buck 13 LXO, another PMIC, and I'm pretty sure this is going to be what we're doing. So it looks like this is going to come from U7700. U7700 also is going to take PP3V8 AON as its input. Okay, so we know kind of in a row what we need. We need PP bus, we need PP, we need PP bus, we need PP bus AON, we need PP3V3, PP3V8 AON underscore VDD main. Kind of tired today, so that's kind of, if you're wondering why I'm talking a little bit slow, that's why. But honestly, I tend to do my best work on stuff like this when I'm tired. So I need to what is this here? Oh, yeah, there we go. Paul S is here. Power sequence. Alright, so this is going to be kind of rough. We're not going to worry about, we're going to refine this later. We're just going to use this as kind of a scratch pad for what we're doing. So PP bus, how did I format this on this other page here? When's a valid okay, here we go. Copy. And I want this to be a little bit, do subheading 2. So charger or battery, once power's there, PP bus, AON, and what I'm not quite sure what that voltage is supposed to be on an M1 board. Let me plug one in to find out, just so I don't provide any wrong information. I really don't want to provide any wrong information, so I'm gonna double check everything. I'm not stuck in my pride where I don't need to, you know, I have no shame in checking something that I don't know. It's not wrong to say you don't know something. You see the people that have most issues with a lot of stuff, you'll find that they're afraid to think that they're wrong on something, and they don't want to check what they already know, and they end up being wrong. So I'm just going to grab a USB-C board that works, a little USB-C. Anel says that I need to pass away. Okay, so what is voltage supposed to be? Hopefully this M1 board works. I think I've already taken stuff off of this, but I think what I've taken off is not critical. So we're going to see. Thank you, Paul. That would be very appreciative. Also, Paul, I shipped your... I don't remember if I already said this once in today's video, but I shipped your paste out. I wasn't really paying attention to what I was saying, and it did not stick in my mind. Okay, what is our PP bus voltage? We're at... I don't think this board works because of how the amp draw is reading. Wait, no, it doesn't. I've taken stuff off of it, but it should work. It's giving us 20 volts, but we should have PP bus here. And what is PP bus going to be? Where's our PP bus fuse? Alright, 12.29, so 12.3 to 12.6. 12.3, it's at 12.3 now. Alright, so PP bus AON, I want to say, I don't think 12.3 is normal. I'm going to put down 12.6 to 13. What does the schematic say? The schematic is often wrong as far as what PP bus voltage is supposed to be. But I'm going to double check here. So we're going to go to power aliases. Where is it here? Power. Power aliases. Where is power aliases? Power aliases 1, page 78. Okay. Page 78. What? Why won't this scroll? There we go. Voltage 13.1. Again, I always think they kind of over-exaggerate, so I'm going to put 12.6 to 13.1 just to be safe. Normal voltage. How do I format this again? Normal voltage. And another thing is we always put about, okay? I see it so often where people will get something like, let's say, 12.5 volts, okay? And they'll say, oh, something must be wrong. No. If the values are slightly out of spec, it's probably not indicative of anything. Reduced from ISO 9240 U5200 that uses what are they calling it? PPDCN AON charger. PPDCN underscore AON underscore CH charger R. It's VIN. The R is important because that tells you it's a resistor. There's a resistor, and this resistor can actually blow if there's a short. So let's figure out where this resistor is. Looks like it's over here. Okay. Yeah. PPAONSW. Okay, from our CD3217s. That's that. Alright, so it looks like now, we don't know this for sure, but it looks like our next one is going to be PP 3V8 underscore AON underscore VDD main. That's going to be our next one. Normal voltage is about 3.8 volts produced from U5700 that uses PP bus underscore AON as its VIN. Period. And then that's all we're going to do for right now. For this sentence. Let's go back over to editing this. And no power. For low or missing. Always check that both USB-C ports are reading the same. One port reading 5 volts and 0.1 to 0.2, while the other is reading 5 volts and 0.0. Is more indicative of a CD3217 issue than an issue with PP bus AON or any of the CD3217s supporting power rails. Okay, now let's form our differential diagnosis. So 5 volts and very low amp draw. 0.00 to 0.02 amps on the 820-02016 logic board. Enter bullet point. PP bus underscore AON short, low, or missing. It's good. Let's see. Command 4. Corrupt M1/bridge OS firmware. Let's see. No, we don't want to do this. Device stuck in DFU mode due to. Now, when your device is in DFU mode, that screws with a lot of stuff, so we're always going to list that. And the 5 volts, 0.0, 0.02, pretty much any 5 volts can be a DFU or recovery mode issue, so we're always going to list it. I don't want you to dismiss a problem based on the reading and then miss something potentially. So device stuck in DFU mode due to corrupt firmware. We're just going to put firmware because the M1 is a little bit different than the T2. Let's see, Command V, missing or shorted T2 CD 3217 support voltage such as PP3B3 underscore S2 underscore UPC PP5V underscore S2 or PP1V25 underscore S2. Let's make sure we didn't miss anything. So you have to remember something. There still can be another issue that's not listed here. Okay, this is just what we know. There's can be definitely another cause list. A list of the differential diagnosis that is not full. I mean, there can absolutely be another cause for this. Is Lewis also live? I don't know. Okay, so PP5VS2 we got. LDO, we don't care about that for this. Yep, we got them all. Okay, so any of those voltages can cause it as well. Now we are also going to put, let's see. Yep, that's good. Another thing we list is non-specific areas of corrosion, because if there's a communication issue between the firmware, it can cause issues like this. So we're just going to list it. Let's see. Corroded CD 3217 or non-specific. Let's see, code CD3217, ISL 9240. Or other non-specific areas of corrosion that PEDS impedes. Let's see. Communication between PMICs and SOC and SOC and other components. Alright, so that's basically what can cause this on this board. Again, there may be other causes, but this is generally the main causes here. Okay, we have this listed. And that's that. So let's go on to our diagnostic steps now. Not that. 1, 2, 3. Diagnostic steps. 1, 2, 3. Okay. So step 1. I always tell people keep a MacBook or something to check for DFU mode. It's not always the cause, but it takes 2 seconds to check. You don't even have to take the board out of the enclosure. So I do recommend you check to see if it's in DFU mode first. Usually I'm going to go on what I had listed for on my other pages I did. Yep, so check if the device is stuck in DFU or recovery mode. This is stuck in DFU or recovery mode. And they did trickery. They did trickery again. The master port is no longer the same port that we're used to. gotta love when they change stuff like that to trick you. Okay, so it's going to be left side, top port closest to the display. User devices in DFU mode, proceed to device stuck in, and I will be right back because UPS is here to pick up a crap ton of packages, so I'll be right back. Okay, we're back. Okay. Okay, so we're just going to remove T2 from this. It doesn't have a T2. I don't want to say M1 firmware because it's different. It's different how it works a little bit. Top port closest to the display. Open Apple Configurator 2 to verify it is or isn't in DFU mode. If the device is in DFU mode, proceed to device stuck in DFU mode due to corrupt firmware in the repair steps below. We're just going to add down here. Yeah, Apple will always do trickery like that. You just have to get used to it. You have to understand Apple's going to be Apple, and they're always going to do it. No matter what you do, or no matter what anybody does, no matter what laws are in place, Apple will always be Apple. repair steps. We're just going to list one. No, we don't want one. We're just going to device stuck in DFU mode due to corrupt firmware. Alright, so we have that listed. Let's move on. I have to say something off topic. Doing something like this with trackpoint on a ThinkPad is so much less painful than with a trackpad or keyboard and mouse. Trackpoint is beautiful. Two, check voltage on PP bus underscore AON. Check voltage on PP bus AON. Place your in DC mode and place the black probe on ground and the red probe on PP bus underscore AON. A good spot to measure from is on the 820/2016 logic board is, let's find a nice spot. So what people have a tendency to do is not take the board out. And that's why when I'm doing diagnostic steps, I like to kind of list at the easiest point. And look at this, we have a beautiful capacitor right here, C5960, C5960, C5960. And then we are going to do about, let's see, 12.60 IC to 13.1 volts equals normal. 12.28 to 12.35 equals, let's see, possibly normal, however, may indicate a communication issue between the SoC and one of the PMICs, or between the SoC and other components, as well as corrupt firmware. Zero volts equals short to ground or absent voltage due to a creation check chat. I haven't checked chat in a while. This is not an open. This is repair.wiki. It is totally open source. Yes, you can fix corrupt firmware on M1. We're going to learn how to do that. Creation problem. Don't want to do that. See to the repair steps below for what's weird is I can't do this stuff on a day that I'm tired. I mean, I can't write this stuff on a day that I'm not tired. It has to be a day that I'm tired, or else I won't get anything done. I'll get sidetracked and work on something else. I don't know if that's considered ADHD or what, but or shorted or absent PP bus score AON voltage. Let's go down and add this repair step. Shorted or absent PP bus underscore AON voltage. Let's apply this. Let's make sure we don't have any formatting mistakes and make sure this looks good. Yep, looks good. All right, back at it. Okay. What am I going to put for the next diagnostic step? Phone call. Be right back. for crap like that. I'm pretty sure that's somebody that's watching this stream doing a prank call, but yeah, I don't have time for that kind of crap. If it was a real customer, I don't have time for that kind of crap. Caleb, log into our phone system and look at and listen to the last recording on the call. Okay. Tim discovered some vulnerability. Yeah, so I don't know if I should talk about what I did to Caleb's computer yesterday, but yeah, Caleb's computer had a serious suffering. Let's see. Check. Can you listen to the call on... I don't know. I've gotten calls like that before, and I don't have patience for it anymore. That could have been a legitimate customer. I don't know, but they would not get to the point. They kept going on about their life story, and I'm pretty sure it was nonsense, and then I heard chickens in the background, so I hung up. Yeah, 1,400 for that is a scam. Let's see. Can I... Recordings, yeah. Yeah, you could hear it. It was actually pretty hilarious. But... Okay, let's see. I don't know if you can hear this, but... Yeah.
Yes, how can I help you? Sorry, I can barely hear you there. I said, how can I help you? Sorry, what was your name again? My name is Tim. Well, it's funny that you should call because my third eldest, Larissa, she was talking about this this last week, and she is very smart. I'll give her that because she was the first in the family to go to university.
You guys get the point. That's...
With distinctions,
Why won't it
we're
stop?
all quite
That was the whole call, and it's probably it's probably a scam. It's nonsense. Anyway, check CD 3217. But here's the thing: I feel bad for people like that because I've had people call that have like dementia or something, and I'm not even kidding. Will bring their laptop in, and then you call them to let them know it's ready, and they forgot that they brought it in. So I kind of have sympathy for that, but at the same time, I don't. Are you supposed to be hearing that? Sure, I don't care. That says the call was recording. So, again, it's an informal call. It's nothing personal was described. It was just like, please, if you call any business, doctor's office, anything, stick to the point. We don't need to know about your family. We don't need to know about what your oldest child has done. We don't need to know about, your brother's lung cancer or whatever. Please skip to the point, what you need, and we'll help you. We don't need a life story, please. I'm not going to delete the stream. I'm not going to make it private. It's literally a clip of a call that is 99.99% chance of being a prank call from somebody in this chat like Corbin. So there's no need to delete that. I'm not going to delete a clip of a video because of a clip of a call like that. And first of all, when you call my store, it literally says this call is being recorded. So, yeah, I'm not, yeah. Check us, support voltages. And another red flag is it was an anonymous number. Anonymous numbers are almost always scam calls. or prank calls. Okay, so check CD3217 support voltages. Let's go over this. So PP5V_S2. PP3V3_UPC. Wait, what? S2_UPC. PP. Wait, no. No, this is after. After. Four. I've made the mistake of access. So our phone system, when it rings to the cell phone, when it rings to the cell phone, it doesn't separate it from calls, and I've accidentally hit the, instead of going in the phone app on my phone to call a customer back, I've called from my personal number. That is the worst thing to do ever, because they'll save it. They will text you at odd hours of the night asking why some pop up. Just keep your personal number private, please. Exactly, murder media. Like, why? What's the point? On one of my Facebook profiles, my license plate has been visible. You could come to the store, you could see my license plate. What are you going to do with the license plate? Nothing. What can you legitimately do with a license plate number? Nothing. I guess you can report an accident or something fraudulently. But that's a fraud. That's a scam. We're just going to substitute some stuff from this one. What's a good easy spot? I like big easy spots that people won't confuse for other stuff. Anything on the top? Anything easy on the top? Are the 3V, are these coils under a shield? No, they're not under a shield. Perfect. I don't like that because it's on the other side of a resistor. How should I say hi to a repair shop? I did it wrong. I brought a device to a tech and told him I didn't need it repaired after he quote me prices and potential issues. I don't know what your question is. I don't know what that question is supposed to mean. 85. Let's see. Okay, these are good ones. C80, 5887 and 5889. C5889. I'm getting hungry. 0.8 volts. Yeah, just 3.8 volts. Point. What the beauty about this is we could just substitute this for the A2238 very, very easily because they're pretty much the same device. Let's see. Okay. Have I eaten today, says Travis. Travis, I have not eaten a single bit of food today, surprisingly. And it is almost 2 o'clock, so I probably should eat something. But I am busy, and I don't have time to eat anything right now. Okay, there we go. That's that one, so we know to fill this in. Caleb is not here. Don't send pizza. I'm fine. I'll go get something to eat. You don't owe me pizza for some bet. All right, so here's the thing. If I'm super hungry and my blood sugar's getting low, you can see that. And look at how steady my hand is. All right, I'm fine. I'll get food in a few. No, I am not eating Pizza Hut. Screw that. That is poison. I'm gonna finish probably this page right here, and then I'll go get food. But we'll see. Caleb has lemon concussion. That is absolutely right. Phone is ringing again. Alright, I'm back. Now, this is something really important because I've seen shorts on, let's say, PP5VS2 that has caused higher amp draw, I think. Let me pull up a YouTube video. I don't remember every single board I work on, so videos are a nice archive for that. Let's look. This is a MacBook Pro, but it correlates. I want to see what I said here. Where it's at, and I can tell you from the. Okay, so we have our bottom case off, and right off the bat, I see some areas of just minor liquid. Part of one today, we have yet another 820. Part of one today, we have yet another 82238 MacBook Pro that does not turn on. So let's go ahead and open this up and let's see what's going on here. Okay, so we have our bottom case off, and right off the bat, I see some areas of just minor liquid. Like on the heatsink, we have some drops, and on the fan, but nothing really too serious, at least in my opinion, so far. So let's go ahead and plug this in. Now, we're still kind of learning about these M1 machines and how they present on USB amp meters, so this will be yet another learning experience here. So, plug in our USB amp meter. Looks like we're getting 5 volts and 0.03 milliamps. Now, on the... Okay, so the 0.03. I'm going to make this more broad here. Shoot. Let's see here. Haven't done A2159 yet. I'm going to though. Alright, I'm going to get our diagnostic steps done, and then I am going to go get some lunch, and then I'm going to come back. But I'm hungry, and I really need to get food. I have not eaten today. Which is fine, I'm used to it, but I notice I'm starting to get a little bit sluggish, so it's time. I like big spots. I don't like little spots for people to measure from. So I'm gonna say CC334 or CC335. Those are under the heatsink. That's not a good spot to measure from. Right here. CF400 or CF500. I like to choose easy areas to measure from because I've seen it so many times where people short stuff out or they just don't know where to measure from. And honestly, right here, this is a perfect spot. Pin 1 of SWV. That's nothing there, just to know stuff. SWV011. SWV011. Pin 1, just so people don't get confused. Okay. I'm gonna stop for lunch break, I think. So this pretty much covers the diagnostic steps. So I'm gonna save this, and then we'll work on this after I eat lunch. So I'm gonna figure out what I'm gonna eat. Um, and that's that. So I'm going to end the stream for now. I will be back shortly. I'm just gonna go grab some lunch, and then I'm gonna work on this probably for the rest of today.